Hello, you are watching Video Notes 610, Solving Quadratic Equations Finale, meaning we've been working on this for a few days and we're ready to try to bring it all together and wrap it up. So if you look at exercise 1, each quadratic equation below needs to be solved using your technology, so a graphing calculator, to determine which methods would be best and try to explain why. So in number A, letter A, I was just graphing it and noticing, here's a quick graph of it, noticing that the zeros are at nice points. So when I noticed that the zeros were at nice numbers, they looked like whole numbers, I thought it probably would be an easy one to factor. The other thing I thought is the quadratic formula would be easy because that works every time. And completing the square wouldn't be bad because that 12 is an even number. Completing the square leads to solving by inverse operations, but the one that I wanted to solve using inverse operations was this one because there's only one x in the equation. One x in the equation makes x easy to get alone. So inverse operations is get x alone and try to solve by adding the 18 over to the other side and taking a square root. But I think that's what they meant by using inverse operations. This one, part B, when I looked at the graph of that, let's see, I have it on page 2 here, I noticed that the roots were not at nice points. They were not at whole numbers. And so I probably would not try factoring because it's going to be not easy to do. Inverse operations, well, it doesn't look like it'd be easy to get x alone, so I crossed that one off the list. But definitely completing the square because the b is positive. I mean even, and quadratic formula works every time. So completing the square because the b value, little b, is an even number, and the quadratic formula works every time. Works every time, as long as you can determine what A, B, and C are. In this case, if we did the quadratic formula, the B value is not there. It would be a 0, but you could certainly still do the quadratic formula. In D, I also graphed it. So let's see if I can find it on my graphing calculator. So let's say we go to page over here. Is that the one? Nope, one more. There it is. I noticed that the zeros, this one over here on the left is not at a nice number, and that one possibly is at 2. If I do trace, I could find that. And let's see. Sometimes this doesn't work well, but we're going to try it. Here we go. One more. There we go. Nope, that 0 is at 2.14. It's not as nice as I originally thought. So I'm going to get rid of factoring as a method because the zeros aren't nice. Inverse operations, well, there's 2 x's. It would not be easy to get x alone, so I'm going to say no to that one. Completing the square, b is an odd number, so as soon as I say take half of b, that would not be a nice thing to do. So I'm going to go with quadratic formula, and basically it's because the other methods were not going to work out so well. So quadratic formula works every time. Exercise 2. So anyways, the point of that whole exercise that we just did was just to make sure that you're paying attention to what you're looking at. First off, I did notice that they were all quadratics. They all have an x squared in there. And then I thought about what possibilities were for solving them. I'm going to solve each of these using the required method and arrange the equations so that they are set equal to 0. They're telling me to use factoring on this one, so I guess it's going to be factorable. I'm going to subtract 8x and add 2 over to the other side. Subtract 8x and add 2 gives me my big fat 0 on the right-hand side of the equation. So you have x squared, a minus 3x, and a minus 10. If you combine those terms, that's my 0. So this should factor. Let's try it. Hopefully you're getting good at factoring. X and x. I'm looking at the 10, and I'm thinking, what numbers make a 10? 1 and 10, 2 and 5. And I like the looks of 2 and 5 because I can sort of think of a 3 when I see them. The signs have to be different, so a positive and a negative, or a negative and a positive. This combination is going to give me a negative 3. If I add 2 and negative 5, I get negative 3 as my sum. So I'm going to do plus 2 and minus 5. And remember then, you set the factors equal to 0. X plus 2 equals 0. X equals negative 2. Subtracting the 2. X minus 5 equals 0. Add the 5. X equals 5. And again, if I were to check this on a graphing calculator, I would have had zeros at negative 2 and 5, which would have helped me change the sign for my factors and check my answers. Okay, solve by completing the square. So we're going to, well, I always like to get everything over to the other side. I'm going to do that anyways. I'm going to add 3x and subtract 4. So add 3x, subtract 4. I now am looking at x squared minus 12x plus 20 equals 0. So this is what I'm completing the square on. X squared minus 12x plus blank plus 20. I'm going to end up adding something in and taking it off to balance it out with my 0. So I start thinking about what this would factor into, x and x. And I have to split this evenly, so minus 6 and minus 6. Negative 12, I took half of it. Now I'm going to square that number, because if I multiplied these back together, that's a 36. If I add in a 36, I need to take off a 36. My perfect square trinomial is x minus 6 squared. And the combining of these two numbers gives me a minus 16 equals 0. Now what I'm doing is using inverse operations. See how there's only one x? I'm going to get x alone. Add 16 over to the other side. So I have x minus 6 squared equals 16. I'm going to take a square root, and when I do, I'm going to put a plus or minus. So I get two values out of that. That cancels. Add 6 in front of the plus or minus. So I had x minus 6 equals plus or minus 4, because the square root of 16 is a 4. When I added the 6 in front, 6 plus or minus 4, I can do that math because 4 is a whole number. There's no more square root. 6 plus 4 is 10. 6 minus 4 is 2. So my answers are 10 and 2. Now I'm going to solve using the quadratic formula, and it tells me I'm going to the nearest tenth, which is my hint to know to go to my calculator at some point. So I need to get the thing in the right form. Subtract 5x, subtract 15, subtract 5x, subtract 15. So if you notice, every time I see a quadratic, x squared, I'm trying to get it set equal to 0 so that I can take a good look at it. X squared minus 8x plus 1 equals 0. So if it says quadratic formula, I'm looking for a, which is 1. I'm looking for b, which is negative 8. Oh, I underlined the wrong thing there. Negative 8. I always like to go to b squared at that point in my head. Squaring negative 8 gives me a 64. And I'm looking for the c value, which is positive 1. Go into your formula. You're going to do the quadratic formula, so I'm just going to warn you, I'm probably going to sing it. Let's go. X equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Now I'm going to plug in my numbers. X equals negative b means change the sign on b. So it'll be a positive 8 plus or minus square root of b squared is 64 minus 4 times a, which is 1 times c, which is 1, all over 2 times 1. So I'm going to do the math underneath the radical. Take that to my calculator. 64 minus 4 times 1 times 1. Let's add a page here. 64 minus 4 times 1 times 1, 60. So underneath the radical is a 60. 8 plus or minus the square root is 60 all over 2. Now, do I need to simplify that radical or not? The answer is no. I'm going to go to my calculator. I'm going to get two answers. So control divide. It's a big fraction. And on the top, I have 8 plus the square root of 60. Okay. And on the bottom, I have 2. Just that bottom box is a 2. Hit enter. So I'm going to write that down for now. 7.8. Yeah, I already forgot that number. 7.87298. 87298. And then I'm going to look at the nearest tenth. That's a tenths place, so it's going to be rounded up to 7.9. I'm going to go back to my calculator. I'm going to highlight that mess and hit enter to backspace and change that plus to a minus and hit enter. No sense in retyping. 0.1270. So 0.1270. Rounded to the nearest tenths place. It does not make it go up. 0.1 to the nearest tenth. Tell me quadratic formula, simplest radical form tells me no calculator. I'm not going to be able to type it in like I just did. I'm going to add 2x and subtract 7 to get my 0. That zeroes out. X squared plus 6x minus 5. Watch your signs. So a is 1, b is 6, b squared is 36, c is negative 5. X equals negative 6 plus or minus the square root of 36 minus 4 times 1 times negative 5 all over 2 times 1. And I'm going to go to my calculator to get the number under the radical. So I always put the shell there waiting to be filled in. So 36 minus 4 times 1 times negative 5. 36 minus 4 times 1 times negative 5. Enter. 56. That's a 56. Now I would go to my calculator and look at the square root of 56. So it's not a perfect square, but if I take 56 and start dividing, I did this in the notes the other day, by 2, nope, that's not a perfect square. By 3, that doesn't divide. 56 divided by 4 gives me a 14, and 14's only factors are 7s and 2s. I'm going to use 4 and 14. So x equals negative 6 plus or minus the square root of 4 times the square root of 14 all over 2. I'm simplifying, so I'm simplifying the radical. It is a 2 rad 14 all over 2. And then I'm simplifying the fractions, if you remember correctly. Negative 6 over 2 and 2 rad 14 over 2. So this one reduces to a negative 3. And this one is just radical 14. So there's my two answers in simplest radical form. In exercise 3 on the next page, the quadratic function is shown in the graph. It wants to know what the turning point is, so go to the origin and count it out. 1, 2, 1, 2, 3, 4. So the turning point is at 2, 4. And use the turning point to write the equation means they want you to do vertex form. So change the sign on the x, put your square, because it's a quadratic equation, I can tell by the shape of the graph, plus 4. What happens when you try to solve for the zeros of f of x? Why can't you find solutions? So if I set it equal to 0, let's just try this. X minus 2 squared plus 4 equals 0. So I'm replacing my function or my y value with 0. And I'm going to subtract 4. And then I'm going to take a square root and put a plus or minus. So it's x minus 2, get rid of the squaring and square rooting, equals plus or minus. Now, I know the square root of 4 is 2, but on my calculator, when I do the square root of negative 4, I get something about a non-real number. So you can't take the square root of negative 4. It's non-real. So there's no real zeros. So if you look at the graph, you can tell there's no real zeros because the graph is floating. Oops, hold on. Floating above the x-axis. In other words, there are no x-intercepts. So that totally supports the fact that there's no real answers. So basically just say there's no solution, because we're only looking for real solutions. So if you think about the graphs of parabolas, they can certainly miss the x-axis. This happens graphically when you solve for the zeros algebraically. You won't be able to find real solutions, just like we just saw. The imaginary, non-real zeros you'll learn about in Algebra 2. For now, you just have to say they're non-real. So let's take a look. Using your graphing calculator, you're going to determine which of these has no real zeros. I'm going to graph them and then show you their graphs. So here's the graph of the first one, and you can see that it does have zeros on the x-axis. So this one, let me just take a look at that again. Okay. I'm not sure exactly, oops, oh boy. I'm not sure exactly where they are, but they certainly are there. They're somewhere there and there. So this one has real zeros. Let's check out the next one. So if you look at this graph, you can see that it's completely above the x-axis. It's floating up there. It does not have any x-intercepts along the x-axis. So this one has, which of the following quadratics has no real zeros? This one has no real zeros. And again, that's because the graph was floating. Doesn't have any x-intercepts. And we will graph the last one and see what that one's doing. Okay, so here's the last one, and you can see that it has zeros. They might not be nice. I'm not sure exactly where they are, but they're there, and that's all the question is asking about. So this one, oh, I already forgot. Okay, there we go. It does have zeros. If you want to give yourself a little sketch to remind yourself what you're talking about, it does have real zeros. So this was the only one that had no real zeros.